Okay, this video is about ellipses, and this is day 2 on ellipses. Yesterday we did basic ones. Today we're going to show you a different type of problem using the ellipse equation to solve. Okay, so just to review for a moment, all the things we talked about yesterday, vertices, center, and foci. Okay, we said the foci were fixed points at a specific constant distance from the center, and that's the C value of our equations. Vertices are the furthest points on the edge of the ellipse along the major axis, okay, the longer axis of the two. Those are considered your vertices, and they are the same distance from the center, either direction. Co-vertices are the furthest points on the edge of the ellipse along the minor axis, okay, and that distance is called the B. A is the distance from the center to the vertice, B is the distance from the center to the co-vertice. So finding A, B, and C are essential. Finding A, B, and C are the essential parts of finding the equation of an ellipse. As you see, that's what we're going to be needing today. Okay, so we're looking to find the equation of ellipse given the foci and the major axis. All right, so let's look at this. To find the equation, we need to know what A is and we need to know what B is, right? C can help us get there, but it doesn't always have to be known. Now let's look at our picture down here with our definitions. What is A, B, and C? A is the distance between the center and the vertice. Did they give us a vertice? No. B is the distance between the center and the co-vertice. They didn't give us that either. C is the distance between the center and the foci. They gave us the foci. We need to know what is the center. So here's how you figure that out. First of all, graph it. Okay. So 8, 3 is one foci. 2, 3 is the other one. All right. Now, if you remember, look at your diagram down here. The foci, the distance between, or right in the middle of the two foci is the center. It's the midpoint between those two. So to find the midpoint, you take the x values. If you don't recall the midpoint formula, looks like this. But it's just averaging the x's, averaging the y's. So I'm going to take 8 plus 2 over 2, 3 plus 3 over 2. What do I get? I get 5, 3. That is my center. Okay? So center is 5, 5, 3. I need this. Then I need to know, okay, now that I know that, and I know the foci, what's the distance between one of the foci? It's the same distance between the two. What's the distance between the foci and the center? So really just count it over. What is this space right here? Okay? Count the spaces. 1, 2, 3. If this is 5, this is x is 8. What's the difference? Well, that's the difference of 3, right? That is my C value. So now I know that C is 3. Now, do we know enough to know B? No, because we don't know a co-vertice, anything about it. Do we know anything about vertices? Well, here's your clue on vertices. It says the major axis is 14. Major axis connects the two vertices. Okay, if the major axis is 14, that means that it takes 14 units all the way across my ellipse. So what's right in the middle of 14? Well, 7, right? So if I go from my center and I go 7 to the right, 7 to the left, that's going to give me my two vertices. Now, I don't really need to know what the xy coordinates of those are. All I need to know is that I had to move 7 units this way, 7 units that way. 7 is that distance A. Okay, 7 is that distance A. And how did I get 7? Because it's half of 14. All right? Now, I know A and I know C. I have an equation. Remember this equation up here? A squared minus B squared equals C squared. That is enough for me to know what B is. So I'm going to plug in the values that I know. I know 7 squared minus B squared equals C squared. Well, that's 9. That's B squared. Fine. So 49 minus B squared equals 9. I'm going to move B squared over, and I'm going to subtract 9 from both sides, and that gives me 40. Now, I could take the square root, but I don't need to because look at the equation. It asks for B squared. So I already know what B squared is. It's 40. Now, my goal is to write the equation. I know what A is. I can square A. Do I know what B is? I can square B. B squared is 40. What is A squared? Well, 49. Now you have to decide, make sure it lines up. If we took that major axis, we would agree that it goes horizontally, right? That means the bigger value for A versus B is going to be under the x because it's along the x axis here. So now I do x minus h. Well, what is h? H is 5. squared over a squared. What was a squared? 49. Plus y minus k squared. What is k? It's 3. Over b squared, and we already said b squared is 40, equals 1. There's my equation for my ellipse. All right? There's a lot to think about here. Just take it in baby steps and you can do it. Let's try another one. Look at this one. All right, look at this problem. It's a little different. Find the equation of an ellipse given the vertices and a minor axis. Okay, the vertices. That's the outer edges of the major axis, right? And a minor axis. So again, what I would recommend you do is just to graph it because you begin to visualize what's happening here. So I need to go out 4. All right, so my first vertex is up here. Second vertex is at 4 and negative 4. Okay, so this is the outer edges of my ellipse. Okay, remember this? Remember? The minor axis, meaning if my vertices are going vertical, the minor axis then goes horizontal. How did I know it go vertical? Because I graphed it. Look at them. They line up vertically. Minor axis is 3. All right? Well, the minor axis is 6, so it's going to move 3 in each direction from the center. That's what I'm saying here. So let's figure out what is the center here. Well, what is the middle point between these two vertices? Well, follow the same rules we did before. x1 plus x2 divided by 2, y1 plus y2 divided by 2. I get 8 over 2, which is 4, and 0 over 2, which is 0. So my center is 4, 0. Okay? Now, the minor axis, let's see. From the center up to my vertex, that's a distance of 4, isn't it? Well, look, what is that called? Distance from the center to the vertex, that is A. So A is 4. B is the distance from the center to the co-vertex. Well, if I apply the minor axis and go out 3, 1, 2, 3, that's my minor axis. There's my ellipse. Okay, and what's the distance here? It's a 3. So that's the distance of B. Now, do I need C? I don't need to know what C is because I don't need it to write the equation. But I want you to look carefully. This is a vertical ellipse, is it not? It's oriented vertically, which means the major axis is vertical, the minor axis is horizontal. So what happens is the A value, which is always the bigger of the two, A value is going to have to go under the y squared because it's vertical, okay, because it's the y. So when I do this, my center is 0, so y squared over, so my equation actually, since it's vertical, is going to be this. So see the difference there? A squared always has to go underneath the longer of the two axes. In this case, the vertical was the longer, so the a squared goes under the y. So a squared is 16, and x, remember it's x minus h squared, so x minus 4 squared over, what is b squared? Well, b squared is 9, equals 1. That's my solution for this, okay? It's very important that you know these words and know their definitions to help you write their equations. And it's important that you take a moment to draw the picture because it puts it into place where it is vertically, horizontally, where's the center. All these things are much more helpful if you draw the picture. Now, I want you to try this one for class, okay? Walking through the same process we just did, I want you to try it on your own. All right? Good luck, and we'll see you in class.